Hey everybody, this is Mr. Mathblog, and this lesson is we're going to find volume of composite figures. So we found volumes of prisms by doing length times width times height, and then here we're going to combine some prisms together. So I'll show you here in just a second. So here's our common core strand, pretty much the same thing we've been doing this whole unit here. So our question is, how can we find the volume of rectangular prisms that are combined? Okay, so here's one right here. So this shape is made up of a composite figures made up of two rectangular prisms that are combined. Find the volume. Okay, so it's like I have this rectangular prism and then this guy right here. There's a couple of ways. Actually, there's more than a couple of ways. I'll show you three ways here. Here's one way. So we're going to break apart the solid figure into two rectangular prisms. So what we could do is just cut off that little top piece right there. And there's another way also. I'm probably some of you guys are thinking of that. Okay, so what we have to do is find the solids of each little piece right there. Find the length, width, and height of each prism. Let me slide that up right there. Okay, so here I know since this is 4 right here, since this is 4, then that's 4 right there. So I know that's 4 or that's 4. It doesn't matter which one you call it right there. Okay, and then also, you guys, the whole length is 10. So if we took off this little 2 right here, that would give us the rest of it right there. So am I thinking that? No, I'm not. I'm thinking of something else. I'm thinking of this right here. That's for the next piece that we're going to do. This whole length is 6 right here. So if we take off this little piece right here, well, this little piece is the same as this little piece right here. So if this is 2, then this has to be 4 to get me 6 right there. So 6 minus 2 would get me 4. So this is going to be 4 inches right there. Okay, so the volume is going to be length times width times height on both of those guys. Let's just slide that up right there. Okay, so length times width times height. Okay, so I'm guessing this is the length. It doesn't matter which one you think though. So, but length times width times height. So I'm thinking 2 times 4 for that guy right there. And then this guy's going to be, this one's pretty easy. This is going to be 10 times 4 times 2. All right, so let's see. So 2 times 4 is 8. 8 times 4 is 32. We get 32 on the green one right there. And then I'm going to save this 10 for last and do 4 times 2 is 8. 8 times 10 is 80, so that's 80 right there. So the total volume is going to be the addition of those two pieces right there. So we're going to add 32 and 80 and get us 112. So the volume of the whole figure is 112 cubic units right there. Okay, so what's another way we can divide those composite figures into two rectangles? Well, instead of doing this right here where we cut it this green guy off on top, what we could do is slice it straight down, and I kind of tried doing my best right there. So if we sliced it straight down, it gets us this prism over here and this shorter prism right here. Now, since that's 2 right there and the whole length is 10, then this little piece right here is going to be 8. Okay, so 8 by 4 by 2. And then this one's going to be 2 by 4 by, this time it's 6. It's all the way down. So the total volume, if we multiplied those, we get 48 plus 64, which is the same as what we got in the other one, 112 cubic inches. Okay, here's a whole nother way. I like to call this the surround and subtract method. So what we could do is get the biggest volume. The biggest volume is to think of the big box that would contain this whole thing right here. So there's this empty space right here. So if we just included that empty space, and the big box would be length times width, and then the height would be 6. Okay, so the length would be 10, the width would be 4, and the height would be 6 right there. So the volume of the big box that would surround that would be 10 times 4 times 6. Okay, and again, I like to save that 10 at the very last, you guys. 4 times 6 is 24. 24 times 10 is 240. Now that's the whole piece right there, okay? So what we're going to do is find the volume of this little empty space right here and subtract it out. It's called the surround and subtract method. At least that's what I was always told. Okay, so let's find the volume of the empty space right there, okay? So its length right here, now the whole length is 10, so if we took off this little 2 right here, I'll write it right up here, this is going to be 10 minus 2, or 8, okay? So that's going to be 8 right there. And then the width is still this 4 inches right here. And then the height over here, it's not 6, it's going to be 6 minus this 2 right there, or 4, okay? So we get 4 on that side over there, okay? So then its volume is going to be, the empty space is going to be 8 times 4 times 4, which is 128. So the volume of just this little piece right here, is the whole volume subtracting off the empty space. So it's going to be 240 minus 128. So I'll do that right down here. Slide that up. So 240 minus 128, we still get the same volume, 112 cubic inches. Okay, let's try another one. This one's got, so the volume of the whole composite figure is still 112 cubic inches. Now, cubic inches can be written like this, or it could be written like this, inches cubed. This just says cubic inches. This is math kind of code language to write instead of writing this all the time. I notice your book likes to write that. But as you get higher in mathematics, we write it like that, okay? All right, so here we go. Here's another one. So find the volume of this composite figure made by putting together 3 rectangular prisms, this one, and this one. So what we're going to do is find the volume of each one of those and add them all together. Okay, so what I need is the length, the width, and the height. Okay, so the length down here is the same as this up here. So this is 4 right here. Okay, I'm sorry, 4. Did I say 4? That's 3 right there. So this would be the length. The width would be this piece right here. So I got to go way over here, and it's the same as this guy right there. So this is going to be 5 right here. And of course, the height is 4. So length times width times height is going to be 3 times 5 times 4. Did I do that right? 3 times, yeah, that's right. Okay, so let's see. 5 times 4 is 20. 20 times 3 is 60. Okay, all right, let's get the dimensions of the middle guy right here. So I'm going to go over here and notice that this piece up here is 5, so this length down here is also 5. We'll use this 12 later to get this piece over here. So the length is 5. The height is this guy right here, which is going to be this 8 right here. And the width is still that 3 right there. Let's put those dimensions in there, okay? All right, so here we go. We're going to go, did I say 3? It's this 5 right here. So it's going to be length times width times height. So 5 times 8 right there. Okay, and then let's see. I like to do 5 times 8 is 40, and then 40 times 5. So I'm doing these guys first. This is 40. I know 4 times 5 is 20. So 40 times 5 is a 20 with a 0. So 200. Okay. All right. Now let's get the dimensions of this last guy right here. Okay. So we know the whole length is 12 because of this 12 right here. And if this is 3 and this is 5, that gets me 8. So that means the leftover from the 12 must be 4. So this little piece is 4. Okay, so here's the length 4, here's the width 5, and then the height is still going to be that 2 right there. Okay, so if we put all that together, and 4 times 5 is I like to do 5 times 2 first. 5 times 2 is 10. 10 times 4 is 40, so the total volume is the sum of those, so we get 300 cubic feet. All right, you guys. I noticed towards the end of the book it starts asking about is this a prism, or is this a pyramid, or what else do we have? Cylinder. So a prism, you guys, and this is a pentagonal prism. A prism it has 2 congruent figures right here, and so it's a pentagon because there's 5 sides, 1, 2, 3, 4, 5. So this is a pentagonal prism right here. We have rectangular prisms, we have hexagonal prisms, you'll find that later. We have pyramids. Pyramids go into a point. Now remember, something that looks like a can is called a cylinder. Something that looks like a soccer ball or a basketball is called a sphere. All right, you guys, I hope that makes sense, and take care.